Hi everyone. We are waiting 2 to 3 minutes before starting the webinar to accommodate for the rest of the attendees who are in the middle of connecting. Welcome everyone. Thanks for joining us and thanks for being part of our community. My name is Valen Kolika and I'll be your host for today. Just a few reminders before starting this call. If you have any issues viewing the stream at any time during the presentation and are using the web browser version of Teams, please just refresh your browser. That should help. And if you are using the desktop app of Teams, please exit and then rejoin back. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security webinars. And all the links that I'll be referencing throughout this webinar, they're also posted on the IM window. During this time, please feel free to ask questions at any time by typing them in the live event Q&A window by clicking on the Ask Question button. Be aware that any questions you post will be publicly visible. But if you prefer, you can post your question anonymously just by checking the box right below where you entered it. Now, we often get many questions on these webinars, and we will do our best to respond to all of them in real time. But in the event, if the answer was not provided, or if you may have additional questions post this event, please don't hesitate to raise them on our Azure Sentinel forum at aka.ms/Azure Sentinel community. If you're listening to this after the fact as a recording, that's also a great place to ask a question. We'd love to hear your feedback on how we can improve these webinars, and you can do so at aka.ms/security webinar feedback. And while you're there, please join our community by visiting aka.ms/security community. That's the best way to ensure you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participate in private previews, you can sign up for that at aka.ms/security private preview. And while you're there, you can request features, give feedback, review our product roadmaps, attend in-person events, or join webinars like this. We believe that the best way to improve our products is by removing any barriers between you, the people that create them, and the people that create them. So we hope you'll join us. Today, Ofer will take us through the learning of the Kusto query language, KQL, that you need for Azure Sentinel. Ofer Shazaf, as many of you know, is our principal program manager from our Sentinel engineering team. And without further ado, I'll turn it over to him. Ofer, the floor is yours.
Thank you, Valon. Welcome, everyone. Today is a somewhat different session than the usual webinars. It's a lab. It's actually homework for you. I will not, since we have just less than an hour, view this session as the lab guide, where I'll describe KQL. I'll do the teaching part, but the recording as well as the PDF that you'll get a link to will be your guide to continue and play around, which we hope would provide even more value than just listening to me now. This webinar is part of a series. The link above, the Sentinel Ninja training link, will take you to the entire series. It has, I think, 16 parts. And we'll discuss how this one fits within the training agenda real soon now. The lab today tries to bridge the gap between general use of KQL. KQL is Kusto query language. It's a query language. It's used by Azure Data Explorer, which is the platform, the big data lake system which Sentinel is built on, as well as other Microsoft products that are based on it, such as Azure Monitor and Microsoft Defender ADP. In this webinar, we'll try to focus on the specific areas of KQL which are relevant for your use of Azure Sentinel. Alongside, the session today would be self-contained, but alongside, you may want to review the KQL Pluralsight course. It's a very valuable general purpose KQL course available online for free. And after you finish this one, which is more KQL than Azure Sentinel, just the right stuff, you may want to go and continue with 2 additional modules that are available in the Ninja training. One is about writing rules, which will do the practical use of what we learned today to write rules, analytic rules in Azure Sentinel, as well as the use cases module that present a large number of examples of how to actually write content, whether rules or workbooks for Azure Sentinel. The use cases are useful by themselves, and they're also a good teaching for your own use cases. In between, today we'll talk about KQL with a focus on what's needed for Azure Sentinel. This is probably the most important URL you'll need today. Valon, actually, it's a good idea if you try to type it into the chat window, because I'll move on naturally, and people will want to have that around. aka.ms/LA demo. It's a playground where you can play, and all of the queries that I'll present today using KQL work very nicely on this playground. So you can see the results, you can modify, you can play around. You will need an MS account, but I tried a few. I think that every MS account will work. There's no cost associated. So that's sort of the lab room for you. I do want to thank 2 people. The first one is Nir Gafni. I hope you'll enjoy the presentation today. Nir Gafni has initiated this deck and lab a few years back, and has contributed a lot, while a large group of other contributors joined him for the journey. As well as Yaron Fuchtman, who's answering your question today and is the world expert on KQL. Thank you, Nir and Yaron. I will not go into demonstrations today. The funny thing being a lab is that you should do that yourself. I do want to acquaint you with the main screen that you'll be using when you use the lab. It's just one of the ways to use KQL in Azure Sentinel. That's the interactive way. That's when you type a search and you see the results. KQL, the way we let you access the data, is used also when you build rules. I mentioned that. When you build workbooks, which are our apps or dashboards, and in other places as well. So it's a key building block of Azure Sentinel. Actually, the uniformity of using the same query language across the product is very helpful when using KQL. It means there is a learning curve. I'm trying to help around it today, but once you know it, you may feel comfortable around all of the features. So let's talk about the interactive screen where you just search. KQL and the database that it supports does have tables. So similar to any SQL, there are tables, and those tables have fields. One of the things we'll see today is that understanding the tables and fields is important. In the Ninja training, there is a reference to the schemas used by many of those sources. Also, as you can see on the left side, the tables and fields are listed, and when you type in things, autocomplete will help you get the right names. You write the queries in between. Something that people often miss is that you can write as many queries as you want in one query window, as long as there is one empty line in between. So you don't have to open another window. There's also an option, the plus on the top left, to open another window. And you see the results at the bottom. As you can see, you see them as in tabular format, but you can expand to see the actual fields. Two important elements to keep in mind is first that there's an implicit time filter that would be used for queries. You can change it, and we'll see later you can also specify a time filter within the query, which will override the default one, which is used just to make it easier for you if you don't want to specify one every time. Also, there's a column chooser. For better or worse, Azure Sentinel picks for you, unless you directly instruct him using a operator called project, which we'll discuss later, which fields, if there's a large field set, to show to you. If the field you expect is not there for one reason or another, you'll need to use the column option to select it. That's the screen that you should get to if you use the link that I shared before, aka.ms/la-demo. Let's get into KQL. And again, I would like to mention KQL in the context of Azure Sentinel. What's useful for Azure Sentinel?
Hey, Ofer, sorry to interrupt. Can you just repeat one more time that link you shared? Just want to make sure that the focus, it seems like some folks are not being able to get it. Oh, LA demo. Okay, just a second. I thought it was lab demo. Thank you.
Oh, it's log analytics. Yeah, sorry for that. Nothing to do with the city. No riots today. It's just, anyways. Pipe. KQL, like another well-used query language called SPL, Splunk query language, is very pipe-oriented. Which is important. If you come from SQL, you'll find that a lot of the language is very similar to SQL. The one big difference is the pipe. What is the pipe? The pipe essentially moves you from step to step. And what it does, it allows you to take the input table and then do something with it and get another table that will continue through the rest of the pipe. If you come from PowerShell, some similarities there, though PowerShell works on streams rather than tables. The way we usually use the pipe in Azure Sentinel would be to get some input data, then filter and prepare it. You don't want all of it. The events that are relevant to your logic, to your rule, or to your dashboard are just part of the events in the original table. And you will also want to prepare, such as parse some fields. We'll see how to do it next. Then you want to analyze. You actually want to do the smart stuff, and we'll see how to do that. Importantly, filtering and preparing usually means that you have rows or records of the same type, maybe additional fields, but a lot less of them. When you analyze, usually pivot, you get a very different table, just a result set, and we'll see what that means in a while. Summarize is a good example of a command that does that. And then you want to prepare the results to be useful for a consumer, an analyst in the SOC, for example, which means beautifying the results, selecting just a number of results, etc. So you have the data, you have the condition, what you want to do, might be simple, might be analytics, and then you have the evidence in the SIM terminology, what you want to get out of this. There is a feedback loop. Sometimes when you analyze, you want to further filter and prepare. So you pivoted on a table, you get a different type of table with a very different X and Y, and you want to filter and prepare. We'll see how to do that. Filter and prepare. Okay, where the data comes, how do you filter it, how do you prepare it for later use? So you choose your input tables, the data, what data you want. We'll see what data is available. That's not the focus of this presentation, so mostly a list. You narrow down on the events of interest, and then you parse and prepare the fields if needed. Sometimes it's not needed. It might be fetching information from JSON, which I actually left for the advanced topics of the webinar. And it might be calculating fields. It might be extracting parts of a long text field. And then once you parse and prepare fields, you may want to do additional narrowing down because you know more. What can be a table? So when I showed you the screenshot, you saw on left the standard tables that are available with Azure Sentinel. You can use them. You can use custom tables that are generated when you use custom connectors to send data in. There's actually a PowerShell command that can let you upload a table to the workspace, which is the name we use for the database. The link here is the link under custom tables takes you to a blog post that discusses the different ways to get custom information in. A table can also be a few things which are more complex than just a single table. Union, which we'll see in the advanced part of the presentation, would enable you to query across multiple tables, so have the same query run across a number of tables. External data will enable you to use an external file as a table. Data table will enable you to specify a table within the query. So for static, it's very good for testing, for example. You don't want to go far and get data in. And stored functions are a way to create a query, which maybe I should go back to that. Keep in mind that the query at the end, if we go here to the right side, actually creates a table at the end. So any query is, at the end of the day, a table. So stored function can help you save a query and use it as if it was the source table. This enables you to build something such as initial filtering and parsing to be available for other users that use the system. One thing I want to mention, I mentioned the advanced topics. I don't know if we'll get to everything here today. Keep in mind that that's homework. The advanced topics is an area which I left. I'll discuss some of the concepts there as we go, as I mentioned in the last slide. But if I will not get to some of the advanced topics, they will be there available to you as part of a presentation. And I try to make the presentation self-sufficient, so it's enough without me talking. But we'll start with the basics, where is essentially the same as the SQL where. That's the way to filter, the way to get less events from your original table. It'd be very, very, it would feel at home to anyone who wrote any SQL or any program. You'll have a condition. The condition would include a large number of operators that are available. String operators, all bunch of them. Notice the regular expression match that is available as well. Numeric ones, lookups. Lookups would be looking in lists, which are another data type that can be used with Azure Sentinel. We'll see a bit of how to create a list later on. And many more. You can also use and, or, and not in between the conditions. So anything you want. One thing to do specify here, interestingly enough, the field designator can be an asterisk and can include an asterisk, enable you to move a bit from a structured query as you experience in SQL into more of a search type capability. The exercise window is something we'll meet along the way. That's where there are queries that you can copy to the playground that Valon typed the address of into the window. They will all generate results. You can look into the results and see what you see, and then modify and look into other stuff as well. The queries here are rather self-explanatory. Let's look at a bit of the fine points around that. First of all, it's very common to start with time filtering. Time generated is the key time field in the Azure Sentinel tables. Performance-wise, Azure Sentinel, like many similar databases, is time-driven, and the shorter the time frame, the faster you'll get results. Notice that I used a relative times and a time range result in order to search for the last 1 day. A go 1 day. As you can see later, it can be 1 hour or 12 hours or months. So this is a very typical initial filter. You can see here that we can continue with normal filters. 4624, those who don't know, is the Windows successful logon event. In general, security event is the Windows security events table in Azure Sentinel. Notice the equals tilde case incentive match operator. Here is a list, a use of a list operator. This list is static, it's in part of the rule, but it can be dynamic. We'll see later how that can be done. And lastly, there's tons of operators. I brought here one which is just very commonly used in the world of SIM, matching a subnet, which is a very common use case. So the number of operators is, at the end of the presentation, there's a link to the documentation, and you'll probably find whatever you're expecting in a query language, a programming language, and more. A lot around analytics, which I won't even start getting into in this presentation. I do want to also mention the search operator. The search operator is a type of a where operator. It's just more flexible. It's not structured. It's inefficient. It will be slower. So it's good for interactive use, but not recommended for content, which is in the SIM world means writing it in rules. The important thing here is that specifying the table is actually not mandatory. So if you just use search and an IP address, you'll search for this IP address across all the data set with the current implicit time constraint that I presented before. So there is a general purpose search in Azure Sentinel. People sometimes miss that. It's very useful. It actually provides very nice results, and it works surprisingly fast. Sometimes it doesn't. It waits to the end, so it takes a few seconds to get the results, but they get there pretty fast. You can do search also as part of a longer expression, not just search and then whatever you want. For example, here I did a specific search for the word guest in the security events table for the last hour. This table, which I won't go into, offers, since it's interactive feature, this shows many ways to use search to be more interactive, to have an easier time when you search interactively. Shortcuts, they all have their similar where clauses, but it's much easier to write them. You may want to see the one before last is actually the search error asterisk and search lab asterisk PC are very interesting because they are shortcuts for simple regular expressions, which is very useful.
There's somebody asking if there's a shortcut for the run button.
Excuse me, sorry?
We have someone asking if there's a shortcut for the run button.
Yeah, Shift Enter, I think. Okay. Yeah, Ron would remember by heart. No, I will not go in. I think it's Shift Enter. I promise to provide the answer.
Okay. Thank you.
But it's a good question. There's a lot of hidden tips and secrets. I did not focus on all of them today. It's more interactive than it seems when you glance at the screen at first. You can, for example, use results to build on the query, which I did not go into today at all. It's more about KQL than about the interactive query builder. Extend is the other operator that's very useful for filtering and preparing. It's there to build calculated fields. Those are not stored fields. They're generated as part of the query and used throughout the rest of the pipeline. So they're added to the table. As I mentioned, the expression language is very, very robust. Nearly any expression you'll think of and even beyond is available there. The one important area that I want to highlight today in the same context that's the extend operator is used extensively for parsing. If you go to the extend exercise, again, those are all parts that you can type in, copy to the LA demo workspace and try them out. You'll see a few examples of parsing. Extract is probably the easiest one. It takes a regular expression, extract one field out of it. Here I'm extracting the resource group from the resource ID that's available in any Sentinel event. But notice there are many other ways to do parsing, and some of them work better for different conditions. Note, for example, that the parse keyword is not even an extend keyword, and it's useful because it parses an entire line in a single expression. So in this example, I'm parsing the sub and the R group from the resource ID in one swoop. A real world example, so things are somewhat more connected to the world. You see the link at the bottom. It's a real Azure Sentinel rule. It's a threat intelligence rule, one of those where, in this case, the data is actually built into the rule, the lookup data. There is a way to do external lookups in Azure Sentinel. There's a whole blog post on that. But here the table is internal. You'll see here the filter we talked about time and about process name in the syslog message. Then, once we got the right events, we need to do the parsing using extract this time to extract the HTTP status code and the domain name, which are used as part of the logic. And then the analysis. The analysis here is simple. It's just another set of where statements, assuming that the status code is successful. The domain contains a dot, and the important one, the domain is part of the domain list above. A very simple rule, but a good example for filtering, preparing, and then analyzing. The result would be all the events that match, that are true. We'll see later on how to further utilize those to prepare results for Sentinel. This is the first lab. There are several labs embedded in this presentation. I'm not going to do with you the labs. I'll let you do the lab at home. I try to make sure that they are all based on what we learned before. So if you review the slides and recording up to the lab point, you'll be able to do that. They might not be easy. Also, I combine hints and guidelines, not to guidelines. I need a spell checker. In order not to make things too complicated, try to go one by one. And then a fast swoop through the answer, which is available, but I want to show it to you now to let you have a grab at it. And let's move to the second phase, analysis. We already saw that in a simple case, analysis is yet another filter, another where clause or search clause. But the most common way to analyze data in Azure Sentinel, and it's a starting point, is the 80-20 rule, actually probably the 90-10 rule. There are tons of options to analysis, but you'll find yourself using summarize most of the time. Summarize is an aggregator. It essentially takes the input stream of events and aggregates into an output. It means that it entirely changes the structure of the table the pipe is very different. It also means that the initial information that you put in may not exist, and we'll see why that's important in the preparation step next. There are many, as usual with KQL, there are countless aggregation functions. You should expect to know all those that are important that you use usually, count, sum, average, min, max, etc. There are a few which are more unique and are important. We'll discuss most of them in this presentation. Argmin, argmax, make list, and countif, and countless more.
For just quickly, folks are interested to know if you're going to pause for the lab or do we do this?
No, I'm
later?
not going to go pause for the lab. That's homework.
Okay.
It would. I mentioned. Thanks, Alan, for mentioning and making it repeat. With the lab, it's a long endeavor. It's few hours. It's homework for you, and the presentation today will serve you as the guide for the lab. When Valon publishes the presentation and recording, you'll be able to get to the same environment and do the labs yourself. Try not to cheat and look at the solution before you do the exercise. Thanks for the question. There are 7 labs, and I'll skip on through all of them. I might not get to the last 2, but they'll be available. So summarize. 2 examples of summarize here. In the first one, note that I did the condition part. I broke the Windows firewall table and filtered on direction and action. And I summarized without any by clause, which means that I just want to get a single count. D count means a distinct IP address count, and the result will be a single number. So I transformed all my input into a single number. It's very useful interactively. You just want to count. In a real rule, you probably want more than that, which is where the second example fits in. In the second example, I'm counting the number of successful logins per user and per computer as the by line at the end of the summarized count presents. And that opens the room for a lot of different capabilities, such as people who logged in too many times or too little. This is a successful login event. 4625 would be failed login, which is a starting point for a lot of brute force rules. Note that I did not name the count field, so I got the default count underscore field as a name. I could have used C equals count to name explicitly the name of the new field that I want. Note that the table you see at the bottom, the reason that the one time I'm presenting a result of a query in the slide, you can see them all in your experimentation, is to see how different it is from the input events. The input events were, as you may have seen in the first slide where I showed the screen shot, sometimes hundreds of fields. Once you summarize, you get a very small number of fields, just the fields you summarized by and the aggregation function field or fields. So it's a real transformation. It's useful. We'll see that it's not always enough. That's the second lab. As you asked and I mentioned, it's here for you to do afterwards. I'm not stopping for that. That will take a lot more time. I'll skip fast through the answer. You didn't see it. I'll go forward. A few variants and add-ons on Summarize, which are useful mostly for interactive use. Again, sometimes when you use queries in a programmatic manner, in a rule or in a dashboard, you want to be more explicit. And when you type fast, you really want to be fast. So distinct and count are 2 shortcuts on Summarize that do very simple things. Count does exactly what you want, you think. And distinct does roughly the same, but distinct count and over a set of values of fields. The 2 at the bottom, again, useful mostly for interactive use, are order by and top. Order by would sort the result list. It's less important when you process and analyze the data. It's very important when you want to view the data. So you want to order. And then sometimes you want to cut just the top X to focus. A nice example of order by, which in many of the examples that you can type in, I'm introducing a new operators. As I mentioned, there's a breadth of operators available for expressions, and covering all of them is way more than I can do in this presentation. So I'll demonstrate it through the rest. So you can see here that in this order by exercise, I'm using case. There's a case operator, which takes essentially condition and result, and in this case it helps me translate the alert severity field into a numerical value so that I can order by it, because you cannot order by the high, medium, low, and informal. You see that the order by is on the new build field, and then I don't really need this field, so I'm using another operator called project away to throw it out. So it's not displayed, it doesn't stand in the way of the analyst. That's part of preparing, which we'll get to next. Now that we learned summarize, I want to go back to a feature of summarize which actually belongs not in the analysis part. Keep in mind that we start with filtering and preparing, move to analysis, and we'll get to post preparation in a minute. The use of argmin and argmax in a summarize operator are actually a filtering option. The reason is that when you use argmin and argmax, return the top or bottom records based on the field you specify. In this case, time generated, so argmax would be the latest record. Because I used here an asterisk, it means that it returns the record as presented. So in this case, I'm looking for the last firewall event for each source IP. It's unique and it's more a filter than an analysis because it does not transform the table. It does not pivot it. It returns the same events, just a subset of them. I decided to present one quiz, but I will not, unlike labs, I will get into the answer now. That's why it's called a quiz, but it's still worth looking into and checking yourself in your environment because it explains well what's argmax about. You'll notice that in these two queries, argmax is placed differently in way of order, after and before the where event ID equals. The difference is that in the first option, we are looking for the last event for each account and then checking if it was a login. So we essentially try to look for newcomers, people whose last activity was a login and they did nothing afterwards, and then count those. In the second one, on the other hand, we first filter by login and then use summarize argmax by account, which will return something which is more fun to think about initially. It will return the last login time for each user. Because we filter just login events in the line where event ID equals 4624, and then check what was the last filtered record by account, we get a list of events which represent the last login for each user. In the first option, we get the list of last events for each user and cut just those that were last logining. So if somebody last action was to read or write a file, he will not appear. I will leave you with the question of which one will return more results. So there's some quiz element. I'll skip on the next slide. I'll move beyond the solution. I'll try to show a real world example of using summarize to analyze data. Again, you see the link at the bottom. It's a true rule that we use in Azure Sentinel. The filter is a filter. It belongs to our initial discussion about getting the sign-in logs, which are the Azure AD sign-in logs, a table available in Azure Sentinel, and we filter for failed login attempts to disabled accounts. That's what the rule logic is about. What we do next is summarize. We summarize distinct applications that were attempted from with the same user and same source IP. This implies that a single a username was spraying for a specific IP address across multiple Azure AD applications which use Azure AD for authentication. And then there is a condition, which is in this case a static one, that it's more than 3. In one of the blog posts in the module about writing rules, I present the option of how to make this threshold dynamic and based on statistics. So we see we use summarize, application count, distinct count of application display name, and that's done by username and by IP address. And we find those IP addresses that try to log in with the same username for multiple applications over the time period of the check. Now, this was a rule. We determined a rule. Preparing means that we want to actually make sure that the result set is useful for the user. We want to make sure that the analyst, in most cases, get good data out of the results. It's a very important and sometimes ignored part of writing a query. If you write it for if you write for yourself, you'll play with the UI. If you write it for someone else, you want to use the capabilities of the query language to make sure that the fields are the right fields. Project is a key operator in this regard. Project will select a number of fields to keep in the result set. As you can see here, it can also do extend. So it can have an expression. You can keep fields, or you can generate new calculated fields in the same expression, in the same command. Note that project away is useful for removing fields without knowing the entire list. We saw it before. And project rename just renames a single field. Both will not reduce the number of fields. Remove will reduce, but will not truncate to a very small number. With project, you actually decide just what fields are available. That's an example that will project. It's not a good one. I need to pick a different one because it uses a very nice function. If, like case before, you see that the functions allow you for a level of logic, rather similar to how functions are used in Excel, for example. And if your naming convention is that a computer contains CEO, because it's a CEO computer, it's an important guy. The mistake here, the reason it's a not very good example, because project means only is important is left, which leaves you with very little at all. I probably should, unless I want to talk about mistakes, should probably update this one to reflect a more useful project. Another important preparation option is again going back to summarize. We'll see in the example in the next few slides that summarize has the side effect of removing data. The result would include only, I mentioned it before, only the aggregation functions, the counts, and the fields that the aggregation was done by, but everything else is lost. It makes sense. If you did not do a summarize by IP address, then a single result might refer to many IP addresses. Make list and make set enables you to keep the data even if not is part of multiple events. It will create a field that has a list value. Make list will just include all the items in the original set, and make set will create a unique set of values. So for example, the command security event summarize make set account by computer will return very conveniently a list of computers and alongside with them, so a row per computer, and alongside them a list of the accounts used on each computer. A very useful query by itself. Let's look at a real world example of that one. It goes back to the same password spray we showed before. You may notice that the summarize action, which was just the part in between, which I did not highlight this time, lost a lot of information, which we want to retain for the analyst that was the results of the query. Very commonly, you want to maintain, summarize incorporated a number of events into a single result. You want to incorporate information about the start time, end time, and count. So how many events incorporated in this aggregation. That's usually done by using start time and end time within the min and the max aggregation functions, and then count, which we met before. You can see here the make set, if you recall, the rule tried to depict a password spray against a more than 3 applications. If you want to remember on the detection what were those applications, make set will create a list of the display names of the applications, which is stored as part of this result. Also, we want to create a number of additional fields. We have a few Azure Sentinel specific fields that if you map to them using the extend or project operators, they will become entities within Azure Sentinel. Now, the next question to answer is where is that data used? The summarize, start time, end time, application set, etc., as well as the specialized fields extended at the end. And the answer is that they are part of the incident. This is the data available to the analyst when he's inspecting an incident. Third, what we call here events are actually the results of the query. So when an analyst presses this events button or the number here, we actually rerun the query on the original time frame, and the analyst receives the exact same results that generated the alert in the first place. Which means that we do want to prepare and make sure. That's, for example, the reason that here we wanted to have the start time, the end time, the count, and the make set of the application names. They will be available to the analyst as evidence. Entities are even more important. They are available through those links at the bottom. So if we assign entities to host or IP or URL or account, they'll be available by pressing those. But they are also used throughout Sentinel for the analytics itself. Very specifically, if you go to the investigation graph feature in Azure Sentinel, which I will not present today, the entities are the core enabler for them. You will not be able to investigate if you do not determine the entities that the alert detected. Probably the last topic that I'll go over today, the rest would be, the advanced would be homework, is visualization. I was somewhat focused on rules, and the example I gave so far were rules, but in many cases, what you really want to do is to go interactive and visualize. Also, that's important as part of dashboarding. So I'll talk a bit about that. The first feature that I want to mention is bin. Bin is a function. It's just a floor function. It just truncates values, but it's called bin because it enables separating multiple events into bins in the summarize operator. If I do summarize count by bin time generated 1 hour, it means that every event is evaluated to the 1 hour floor value. So full 1 hours, 3 o'clock, 4 o'clock, 5 o'clock, and then count it. And we'll get a number for each hour. That's the base for charting. It's also the base for a lot of analytics. So I'm presenting bin as part of charting, but many times when you want to do a time series analysis, you'll use bin as well. The 1 hour here can naturally be any time period. It makes sense. The render operator is used specifically in order to create different charts and graphs, and those are some of the supported visualization options. You can, once you have a table, if it makes sense, also from the UI visualize it. You don't have to go back to the query. This is a visual exercise. Time constraints, I will not do it here, but try to look into it. And then a lab and another lab. I love our work here. I will start with the advanced topics. I'll go just as far as times allow. I might prolong. Should I stop for questions, or that Yaron and team is handling?
Yeah, we can stop for a bit, although they are answering questions, but perhaps.
So I'll use the time for speaking. The advanced topics are important. I'll probably skip questions for today. And we'll summarize, but we'll take a look at all questions, and we'll try to actually include them in the presentation when published or a bit later on, as we did in previous webinars. So the first advanced feature I'll describe is the let statement. It's a structural element. It makes writing queries nicer. It enables you to declare and reuse variables. We actually saw that in some of the examples I brought. But let statement is more powerful than that, because it can also let you declare dynamic tables or lists. The first one is actually static. It uses the data table operator, which I mentioned above and said I will mention again in advanced topics, to create an inline part of the query table, very useful for testing. But it's also good for structure, to get the data table out of the actual query. You see here that it's actually a lookup. Note that once the data table has just one field, it's also used as a list in the in operator. The second one, again, a let statement, but here I actually declare a whole query as a named statement, which enables me to use it later on as the starting point for any query. So low activity counts becomes a table to be used. In this example, I'm using let, so it means that it is part of this multi-phased query. You can also save a query as a function, and then low activity counts become something that any analyst or user can use as a starting point for investigation. I'll mention in brief the materialize statement. When you use the last bit I mentioned around low activity accounts, you actually, the normal let uses is syntactic only. So the query is incorporated as is in any use of it. If you want to make sure that the same result set is used over again when two result sets are used, for example, here, there's a union between two replicas of low activity accounts. Not a very smart example, but it does serve to show what materials is about. You want to make sure that not because time moved on even slightly, the result did not change. Use materialize to fix the result set rather than the query as part of the usage later on. Of course, here the query can be written much more simply. The union operator, a very important one. Again, another one I mentioned up front, can be used as the tables, the data source. It enables you to combine multiple tables as your starting point if you want to analyze more than one table in your query. It will combine all events from the one and all events from the other. No logic around the joining. We'll see the join in the next slide. The one thing that you can determine is if you'll get only fields which are common to both sources, or you want all fields across both sources. Usually always one or the other is the right one. Also notice that the actual name of the unified tables can include a wildcard, so it can be pretty extensive. We saw in the search at the beginning that I used union asterisks to simulate search. There is a lab about union, which I'll skip for now. And then one before last, the join operator. The join operator is the key of correlating multiple data sources or events. It matches two tables, but not combining all of them together, but matching them on matching fields. And you see there are many options here. You can join on just if the records which match on both sides. You can match those that match on one side and extend this information from the other side, etc. And you can full outer, which is just like union. The inner join is get me just the matches. The others serve essentially to extend data in one table with information from matching records in the other table, which implies enrichment or lookup. For join, there is, again, in the Ninja training, in the rule writing section, there's a whole blog post around correlating using Azure Sentinel, which includes example of join. The last element which I present here, but I will not get into it, there are labs here, so you can dive deeper. The cloud information, cloud events often include dynamic JSON content, and KQL has all the capabilities to analyze and work with JSON content, and the exercise and the lab will enable you to go there. Lastly, not a lot of links. In the last slide, you see the open playground option, which is the LA demo that Valon presented before, as well as important documentation pages. With this in mind, I'll give it back to Valon if there is one or two important questions that the team digged up that's worth mentioning to all, and then to summarize.
Sure. Thank you, Ofer. We have a question, although, as you mentioned, what we'll try to do, because there's many out there that are not answered, we'll compile like we did last time and then send out the answers as part of the deck. So there's one out there that has been any guidelines for the dynamic tables. In T-SQL, there are lots of gotchas if the dynamic table is too big or not dropped.
I'm not sure I have the answer up front. One option is not to use dynamic tables, but to use external data. So you can use data from an external table stored in a file. If the capabilities of the dynamic table are not up to speed, the external data is supports very, very large tables.
Okay, thank you. Alex is asking how to identify data exfiltration, specifically for the uploads to the cloud apps such as WhatsApp, Dropbox, Google Drive, etc. And he's saying that he can't find a reliable way to do this.
Tough questions today. I'll explain why. I'll pick on. No, I didn't want subtitles. I really didn't want subtitles. I wanted to pick a slide, probably the important one to finish here. So it's a journey. The webinar today was very much about KQL as needed for Azure Sentinel, but not about use cases. And your question is very much in the rest. I'm starting to think about the answer. I don't think I can formulate it here. We would love to touch base with you, maybe engage you with our research team to teach more, and then they might do a webinar on the results, adding to model 11 probably about the use cases. So I didn't go as far as talking about how to implement specifics. I tried to give the building blocks today only.
Okay. Well, thank you, Ofer. Just some reminders before ending the call on the upcoming scheduled webinars that we have. On June 15th, we have the deploying and managing Azure Sentinel as a code. And then on June 23rd, we have multi-tenant investigations. And then what we have for the save date as of right now, which may change later, is July 9 for the workbook deep dive visualization of your security threats and hunts. And for signing up and registration, you can go to aka@ms/security webinars. Now, as mentioned, there's quite some unanswered questions, and we will wrap that up as part of the deck and publish it. And but if you have additional questions, you can always visit us on our Azure Sentinel forum at aka.ms/Azure Sentinel community. Thank you, Ofer, for a great presentation. Thank you to the rest of the team who helped answering the questions. And most of all, I want to thank you for being a part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.